Hello students, today we will start time domain analysis. Okay, so in this time domain analysis we have to study two time response, for example transient response and steady state response. So first of all we will discuss about the transient response. So what are the transients? Transients are nothing but the disturbance. See, we have studied in electrical system as well as mechanical system, if energy storing elements are there, for example in case of electrical system there will be inductor, capacitor, these two are energy storing elements, and in case of mechanical system mass and inertia are the energy storing elements. So as we know that these energy storing elements has the property that it will not allow sudden change. Okay, so it will take some time, to accept that change. Okay, so whatever disturbance is there in the system and time required to settle that disturbance is called as a transient. Okay, so I hope you got the concept of transient. If there is a sudden disturbance in the system, so time required to settle that disturbance is called as transient response. Okay, so I have shown here one output response. Okay, first of all, see here, time response of control system is divided into two parts. Okay, time response of control system is divided into two parts. Number one, transient response, and number two, steady state response. So steady state means, as the name suggests, there will be the settled response. Okay, so this response will continue up to infinity, and this output response, see, output can be electrical or mechanical. Suppose we are considering electrical output, in that case output can be the current or the voltage. Okay, but see here, actually this is the output response. Let's assume any output response. Okay, so what we are doing here, look at this is the output response. So if there is a sudden disturbance in the system, we can see that there is a change in the amplitude, or amplitude is increasing. What is this dotted line is showing? Dotted line is showing the reference input. Dotted line is showing the reference input. Means output has to follow according to the input. But you can check that here the output is suddenly changing and it is taking some time to get settled. Okay, so time from which the disturbance is created and time required to settle that response, you can check here, time required to settle that response is called as transient response. Okay, and once the transient response will die out, okay, you can check here, output is now following to input, but there is some margin. Okay, we cannot say that the output is exactly matching with the input, but there is some margin that we will see later on while discussing the time response specifications. Okay, but look at this, once the time response will die out, the steady state response will start. Okay, so I hope you got a concept of transient response and steady state response. Now see here, the total output C of t is given by Ct of t plus Cs of t. What is Ct of t? That is output because of the transient response. So this is Ct of t. Okay, and the output because of steady state response is given by Cs. So total output is given by Ct of t. Okay, now see, next we have to see the test signals or test input signals for transient analysis. Look at this, test input signals for transient analysis. See, we have studied this input in network theory also, but we will revise because we have to obtain output. Okay, so output will change depending on the input. So what are the standard test input? Number one, look at this, step function. Okay, so as the name suggests, step, so there will be the step just like the 0 1 1 0, like that. Okay, so you can check that here the output, or here this is actually given as input because we are now discussing with the standard test input. Now look at this, here the input is changing from 0 level to the higher level. Now the amplitude of this higher level is represented with A. Okay, so this will continue up to T. but there can be the possibility that the level will change from 1 to 0, that is from A to 0. Okay, so there will be the steps, so it is called as the step signal. Okay, now look at this, how R of t is given. R of t is constant, so what is value of R of t? That is A. So R of t is equal to A. When you will get A for t greater than equal to 0, you will get the input R of t as A. Okay, now see, for in time t less than 0, R of t will be 0. We are not getting any input here. Okay, now see, next we have to take Laplace transform. So Laplace transform of this R of t is R of s. Okay, now here you have to take Laplace transform of constant term, so this will be A by s. Okay, now see, if A is equal to 1, just now we have discussed if the level is changing from 0 to 1, so here A is nothing but 1. So if A is equal to 1, R of s is equal to 1 by s. So that is called as unit step input. Okay, suppose we are getting R of s as 1 by s, so it is called as unit step input. Okay, so we have to discuss the output response depending on the input response. Now next, look at this. Second response is actually the ramp function. Okay, so what is that ramp function? Ramp function is nothing but a linear function. Look at this. The signal which starts from 0 and increases linearly is called as ramp signal. The signal which starts from 0 and increases linearly is called as ramp signal. So we know the equation of straight line. What is equation of straight line? Y is equal to mx. Okay, so m is slope. So here slope is given with a. Okay, slope is given with a, and what we are considering on y-axis, that is nothing but r of t. Okay, so equation of straight line, it will be r of t is equal to slope m into x. X is nothing but time, so r of t is equal to at. Okay, so when we are getting the this response, when t is greater than equal to 0, we are getting response. For t less than 0, no response will be there. Okay, now again we will take the Laplace transform of this input, that is R of s. Okay, so as t is there, so this will be a by s square. Okay, because we know the Laplace transform of t raised to power n, it will be n factorial upon s raised to power n plus 1. Okay, please remember, n factorial upon s raised to power n plus 1. So this is R of s is equal to a by s square. We got this input. For a is equal to 1, again if the slope is unity, okay, here a is different. Okay, here a is amplitude and here a is low. So if a is equal to 1, R of s is equal to 1 by s square. So what we will say to this? We will say unit ramp function. When R of s is equal to 1, unit ramp. This is called as unit ramp. Okay, this is called as unit step when we are getting R of s is equal to 1 by s. So this is unit step. Now see, third one is parabolic signal. We all are familiar with this response, that is called as the parabolic. Okay, or we can say the exponential response. Now look at this. R of t is given by at square by 2. This response equation is given by at square by 2 for t greater than equal to 0. Again we need to take the Laplace transform. Look at this. For t is equal to, for t less than 0, no response will be there. Okay, take the Laplace transform. R of s is equal to a by s cube. Again we will do the same thing. Substitute a is equal to 1. We get R of s is equal to 1 by s cube. That is called as unit parabolic response. Okay, so this is unit parabolic. Okay, now fourth one is the impulse signal. Okay, so what is that impulse signal? You can check this is the response. Okay, I am showing this with delta t. Why I am showing this with delta t? Because at t is equal to 0, look at this, at t is equal to 0, we are getting delta t as infinity. Okay, it is increasing continuously. Means when t is equal to 0, we are getting amplitude, we are getting a response. So see here, the definition is the pulse for which the duration tends to 0. The pulse for which the duration tends to 0 and amplitude tends to infinity. Duration tends to 0 and amplitude tends to infinity is called as impulse. Okay, so impulse response is given by delta t is equal to 0 for t is not equal to 0. Okay, and it will be infinity for t equal to 0. Look at this, when t is equal to 0 we are getting response, so this will be infinity at t equal to 0, and delta t is equal to 0 for t is not equal to 0. Okay, so these are standard test inputs. Okay, that is step function, ramp function, parabolic function and impulse signal. Now in next we will see the response of first order system. Okay, so depending on the input how we are getting outputs, that we will see with the response, output response of first order system. Okay, so thank you students.